Greeting, Professor. My name is Jirakit Ruengsanti, and my ID number is 64105508871. And I'll be presenting the mini project one, combinational logic circuit design. So let's get to the preface. So this academic report is a part of course 012052441, digital circuits and logic designs. The purpose of this making is to demonstrate the capability of knowledge improvised and to gain more skills in the electrical engineering field. Moreover, with more experience, an individual is one step ahead and can perform well in case one might seize a chance to apply such profession in the future. Briefly, this report displays how 7-segment works on logic sims program, and furthermore, several modes are added to make the circuit system more interesting. I will explain these modes later. There are 3 distinct modes. Mode 0, where the system doesn't display any number on the panel at all. Mode 1, where the student ID is shown, and mode 2, at which the tools complement of the binary system is displayed. And hopefully the reader gains more knowledge from inspecting this report. Nevertheless, criticism and comments are well expected. The author is hereby to apologize for any mistakes so far. Thank you. So here come the equipment. I use 2 7-segment displays, 21 AND gates, 7 OR gates, 8 inverters, and these IC for 1 chip each, and 7 4-to-1 multiplexers, in a total of 48 equipment. Let's get to know the 7-segment display first. A 7-segment display is a form of electronic display device for displaying decimal numerals that is an alternative to the more complex dot metric display. So the output is displayed to any position from A to G, including the DP, which is stands for the decimal points, according to the value 1 or 0 of input connected to each channel. Here's the channel I mean. Sorry. Oh, no. Yeah, here's the channel. It's consists of 8 channels, like 1, 2, 3, 4, 5, 6, 7. Sorry, 7 channels. My bad. 1, 2, 3, 4, 5, 6, 7. And to for example, if you can picture, so for example, if you happen to make the display show number 3 in this form, I mean, yeah, we must switch on the input A, B, C, D, and G to make the following figure. A, B, C, D, and G. G is here. So for example, it's like this. In order to make 3, right? We have to switch on A, which is this one, A, and B, this one, and G, this one, and C, this one, and D, this one, to make it look like this. All right. So here's the system layout. Once again, I will show you the layout. This one is a full layout. Here's the full layout, and I will explain everything step by step from here. So remember that I mentioned I'll explain modes later. So here comes the modes. Mode 0, it doesn't display anything, or it just called the system off. The system just go inactive because there's no power sent from these input. Okay, so here comes the mode 1, where M1 and M0 equal to 0 and 1. So basically, you know, we just poke the mode here, poke it like mode. Wait, so we're going for the mode 1. You just make it 0 and 1, 0 and 1. Here comes the mode 1. Okay, I'll get to the detail. So its mechanic is that the student's ID is displayed based on the following input from the table digit. Table digit by digit. Since the ID only consists of 10 digits, the input values far beyond 1011 from the binary codes 1011 from the binary codes is 5, 6, 7, 8, 9, 10, 11. So the number that far beyond 11 is considered as don't care right here. Just like it's said here. Like for example, my ID is once again 64105500871. So here comes the table. Just you just implement the knowledge I gave you from this slide, where we have to switch on each channel, right? So for example, if we were to display number one on the 7-segment display, we just switch on BC channels and just switch off A, D, E, F, G channels to make it show one. So so here's the ID and the segment display. Set 6, right? Which is switch on A, C, D, E, F, and G channel and switch off just only D channel. And the rest just don't care. It surpassed the number 10, sorry. Actually number 9. Yeah, it surpassed number 9. So we take all this information, all the codes, all that I write it here into the K map. So the procedure and the result after converting each into K map will just look like this. Like for example, A will get like this 00001, right? 0 0 sorry 0000 will get 1, right? We'll get here 00001, just like that. Okay, let's not wasting any time. From the table we can get the equation just like A is equal to B1 or B2 or B0 prime and B3 prime. And we just repeat this and we just calculate the result and make it into a formula of Boolean equation. So and thus we bring all these results to form a circuit. The circuit I mean is like this. Let's get to the mode one first. All right. So for example, letter A, right? We get B1. Okay, it's a letter A. We get B1 or B2. So we drag the wire. Sorry, let's get to the editing mode. We drag the wire from B1 and connect it to the OR gate, and B2 also connect to the OR gate, and next one is B0 prime and B3 prime. So we connect to the gate, so B0 prime and B3 prime into the and connect those three into the AND gate. OR gate, and then we get the answer. And then we get the output A. All right, and then we repeat these steps and form a circuit. Now we get after we connect everything and make it into the output A to G, right? We just have to wrap them all and put it in a small box and name it mode 1. I'll show you. Here's some. Here it look like mode 1. We just basically drag the folder mode 1. So, but first of all, we have to add the folder, sorry, add the file into this folder by just click on the project, add circuit, and we name the circuit set. We name mode 2, and then we click OK. In this case, I just click already mode 2 right here. It will show right here. But let's get to the mode 1 first. Okay, so to implement mode 1 into this circuit, we just drag it out, like basically drag it out, and connect the wire, whatever, and connect the wire into this mode 1 in a form of small box. And moreover, we can inspect this one. We see the magnifying glass icon, click, and now we get to see the what's inside. All right, so let's get back to the main circuit. Let's delete this one first. All right, delete this one. Okay, wait, let me check something. Okay, sorry. Where are we now? Okay, we at the we just finished building mode 1. Okay, so here comes the mode 2. Pardon me. I will stop. Sorry, I'll pause recording at this point and I'll continue. Sorry for the inconvenience. So let's get back. We're going to talk about mode 2, which M1 and M2 is equal to 1, 0. So basically, you, as I mentioned, sorry, I have to delete this one first. So as I mentioned, you just poke 1 and 0. Sorry, poke M1 and M2 to make it 1 and 0 like this. Here comes the mode 2. All right. So the mechanic is 50. The number of 2 complement is displayed from the 4-bit 2 complement system. The number range is in between -8 to 7, just like in the table, like this. Okay. So for example, 7, the number 7 in 2 complement system is 0, 1, 1, 1 in binaries. And at the same time, if we want the number 7 to become negative, we just add 1 in front. And it not just add 1 in front, I'll extend the step. So here it comes. Just the same way to calculate 2 complement from binary, just like I said. When we input 0 to MSB, the number is positive. However, if it's 1, the number is negative. MSB is the digit in front of the binary. We must rebit or do the 1 complement first and then add to the result. Finally, we will acquire the answer. So we just rebit it and add 1. The first step that I explained to you previously was wrong. This is the right step. Sorry for the inconvenience. Let's come to the installation. First step is to connect input B3, B2, B1, B0 into inverters. Let's get to the mode 2. B3, B2, B1, B0 into a converter right here. All right. Sorry, inverter. After we connect to the inverters to complement the number, then Then install the IC74LS157 multiplexer, which is downloaded separately from the main program. I will show you the source later on. The procedure is done by connecting it with having enabled connected to the ground, while having selected connected to the input D3 right here. So what I said earlier is that we connect having enable connected to the ground, right? Enable connected to the ground, and then having selected connected to the input D3, selected here and connected to the D3. All right. Then we have to input B3, B2, B1, B0, link it to A4, A3, A2, and A1. All right, I will show this one first. I'll show this one first. We have the input B0 to B3, right? And then we connect it to this one, A1, A2, A3, and A4. And we have its complements connected to the B1, B2, B3, and B4 right here. So what I mean by its complement is the one that run through the inverters right here. It's become the complement of such inputs. All right. And next step is to bring out the output from the previous stage and bind it to the IC74LS2A3 binary adder, or so-called the 4-bit binary adder with fast carry. Bring out here what look like the IC IC74LS2A3. Just look like that. Well, first, let me show. By the way, let me show you how to add these chips first. So we download it from the website. The one that I choose is the GitHub, the code, and then we download it, and then I unzip and then extract it into my file of choice. And after we get that, we click load library, yeah. And then we go to the logism library, and here it looks like with and here it looks like after I finish downloading it, I will click this one and this one and this one also. And after I open it, it will show you like this. Yeah, you see the logic IC7400 series. Yeah, you can just click it and then drag whatever you want outside. It looks like, for example, the 7473, it will look like this. But we will not be using it anyway. So let's get to another point. Wait, let's get to another point. We connect such output that we get from this step into its A4, A3, A2, and A1. You see A4321 right here, right? All right. Connect the output into these thing. Get that. And then add one in the binary system. The way we add one to the binary system, we attach B2, B3, and B4 to the ground to make the number become 0 and bring the input B3 and bind to the big B1. See the B3, B2, B1 right here. Sorry, B2, B3, B4 right here. We attach them to the ground, and then input and then we put the input B3 bind to the big B1 right here. All right, get that. then bring the result of the previous output to join IC74LS48, so-called the BCD to 7-segment decoder to install, bring out Y1, Y2, Y3, and Y4, and connect it to D, C, B, A respectively. So here's like, so we bring out the previous output and join DCBA. So DCBA, okay. The previous output was Y1, Y2, Y3, Y4, and count. No, it don't count this one. Just Y1, Y2, Y3, and Y4. All right. So and ultimately we will have the whole system connected to the 7-segment display, and it will shall show the results. It will show the result like this. That we that after finished, we wrap it up just like what we did to mode 1, and then we extract it into the file called mode 2, and in this case I just called mode 2. And then when we were to connect the circuits into the main system, just drag it out and then connect it to wires. All right. Oh, let me change to this one. Okay. To display the minus sign from the next panel, we gather input B3 and M1 and link them to AND gate, then bring the result output to connect to G of the 7-segment display. If both active, it can be assured that it enters mode 2 and has negative sign. So I'll just show you the result. For example, if mode 1, right? If according to the table, this table, if we enter 1, 1, 1, 1, it shall display negative 1, right? So let's get it 1, 1, 1, 1. Here comes the result. Negative 2, 0, 1, 1, 1, 0, 1, 1, 1, 0. Negative 8, 1, 0, 0, 0, 1, 0, 0, 0. Oh, okay, there's an error right here. I'll fix it later. By the way, I haven't shown you the result of the mode 1. This mode 1 is here, right? So according to the table, if we input 0001, it shall display number 1. Okay, change mode 0001. Okay, 1. Next 0010 shall display 7. 7. 8. 0011 to display 8. 0, 0. Oh, sorry. 0011. 1. I just got a problem right here. Wait, let's. All right, I'll fix it later. I'll take. Okay, I'll take to the next step. The mode manual, just like I explained earlier, to make the mode become inactive or mode 0, you just poke switch M1 and M2 to make it 00. And likewise, to enter mode 1, you just put it, make it 01, mode 2 10, and mode don't care. Just code don't care. You just make it 11. And let's talk about the Murex installation. To implement Murex, or so-called the multiplexers, right here. Let me show you the multiplexers. The multiplexer are these of the little tiny thing right here. So to implement 4 to 1 murex by, so we are going to implement 4 to 1 murex by having M1 and M2 as a selector and then connect ground to input 0 of murex, ground to sorry, wrong button. So we connect ground to input 0 of murex, and then having M1 and M2 as a selector, M0 and M1 right here as a selector. Yeah, yes, selectors right here. All right. And after that, we bring out the output from mode 1 and mode 2. Here's the output of mode 1 and mode 2. Let's turn off all the fish. Here's the output. We connect it directly to the multiplexer. And lastly, connect all the results we get here to the inward, to the 7-segment display panel right here. And let's say we activate some mode 1, for example. See the result is displayed on this panel finally. And this is how it works. So overall, the problem and solution, just like I explained about the problem earlier, when the errors occur, we are obligated to look through every step thoroughly, and it takes a lot of time. So my solution is just, it takes some perseverance. Most of the errors are fixed by recalculating the formula in mode 1 and reconnecting all the wires in every mode, of course. But still, there are some noticeable mistakes, and I'll take it as a case study to show you the errors occur sometimes. Another problem is that the ICs aren't provided in programmed presets. They are needed to download separately, but the problem is fixed by downloading it in the internet, on the internet. Just like I showed you, the website is called the GitHub. It's the way to download it. It's easy, and you'll get it right in front of you. So that's it for the presentation. Thank you for listening, and I hope you enjoy the video clip. Thank you so much. Goodbye.